Hello everyone, I'm Lee. In this video, I'm going to show you the concept of pointer. So let's take a look at this pointer declaration. So int pointer, its data type is a pointer to int. So this star means a pointer to int. That means int pointer is going to contain the address of an integer. So now let's take a look at this ampersand operator. This means address of. So we take the address of int value, this int val, and put it in int pointer. So now int pointer contains the address of int val. Okay, and another new operator is called dereference. When we dereference a pointer, it will access the memory the pointer points to. So when you do dereference int pointer 20, that will put 20 into int val. Okay, and now another new operator called new. New will be executed at runtime. So new int essentially is asking for an integer at runtime. So new int will create an integer memory space and return the address of that anonymous memory. And now we put the address into int pointer. So int pointer remember where this anonymous memory is. So to access this anonymous memory, the only way is to use dereference operator. You dereference int pointer and access that memory. And about new, every time when you new something, that means you ask memory at runtime. The compiler doesn't know about this. You have to deallocate the memory by yourself. So when you say delete int pointer, it didn't delete this int pointer. It deletes the memory int pointer points to. In this case, it deletes the memory about this newly allocated integer. Okay, now let's take a look at dynamic array. So this array we're all familiar with. It's called static array. And this one, you see int array dynamic is to be a pointer to an integer. This is how we allocate the memory for this dynamic array. So we say new int capacity. So take a look. This one will happen during runtime. That means capacity can be determined at runtime. And this capacity has to be determined at compile time. It's static array, and this one is dynamic array, so you can postpone the size determination at runtime. Okay, so that's how you create a dynamic array, and that's how you delete that dynamic array. So every time when you new something, you need to remember to deallocate that part of the memory. So how do you use a dynamic array? It's identical to how do you use a static array. So take a look at this. How do you access individual element? And when you dereference the int array, that dynamic array, actually that what's inside that int array is the address of the first element of the array. So when you dereference this address, you get to the first element of the array. And this is array. It's called pointer arithmetic. When you plus 2 to this int array, what happened is you got to the pointer to the third element of the array. Then you dereference the pointer. So essentially, it's this one. It's a subscript. The subscription operator, the bracket one. Okay, and the pointer does have type. It could be an int star. It could be an address entry star. So any data type, it could have a pointer to point to that data type. So in this case, this addr pointer is supposed to contain the address of an address entry object. So this is how we allocate the address entry object. And this is how we access the name member of that address entry. You first dereference the pointer to get to the object, then do the member access. And this is a shorthand notation. The big arrow is equivalent to this notation there. And again, you have to deallocate the memory, allocate it here. And similarly, we can create a dynamic array of objects. Here we say address pointer, which supposed to contain the address of a address entry object. We create the array. So that means this pointer is pointing to the first element of this array. And you do some work with the array, then before you're done, you need to deallocate a memory for the array. Thank you.